Well, question 7 is a bit of a challenge because you've got this 1 over x squared here. So when we're going with our little bit extra, we're doing 1 over x plus h all squared minus the 1 over x all squared, and then we've got to divide that by the h, and it's the limit as h tends to 0 for all of that. Well, you've got to do some fractions for that then. The fractions part here is going to be, we've got 1 over x squared plus 2xh plus h squared minus 1 over x squared. Now you certainly just can't take bits like that because you've got to have the common denominator here. So the common denominator for these two things, this is going to be x squared over x squared plus 2xh plus h squared minus this part here, x squared plus 2xh plus h squared all over that thing again times by x squared. So there's your common denominator here. So when we're taking those things away, what we're going to be left with is minus 2xh minus h squared, so look, those two things cancelling out again, all divided by the x squared that we had before and the x squared plus 2xh plus h squared there. And we're trying to find the limit as h tends to 0 of all of that divided by h. Well, we've got some horrible fractions going on there, but if I just divide that top by h, that will help us. So we've got minus 2x minus h over the big thing. Should we just write that as x plus h all squared now then? Now what happens as x tends to 0 for all of that? Well, sorry, as h tends to 0 for all of that. Well, as that gets closer to 0, that top bit there is going to be getting closer and closer to minus 2x. This thing here, the x squared, that's not going to change. But as this gets closer and closer to 0 here, this thing here is also going to get closer and closer to x squared. So we've got minus 2x over x to the power of 4, and using our indices powers rule, cancelling one of those x's, we get minus 2 over x cubed as we were asked to get.